Okay, looking at your work, it looks like you're trying to use the formula opposed to doing the tree, the probability tree. I always recommend do the probability tree. I hate memorizing formulas, and they tend to get people confused. So the idea here that I always try to follow on this is identify your, the book says this is A and A complement, then this would be B given A, B complement given A, and then this one down here would be B given not A, and B complement given not A. So the first thing we're going to do is figure out what is A, what is B. So we need to look for which thing up here are they giving us probabilities about where it's not conditional on something else already have occurred. So we're looking for the event A so we can define it. So where I'm seeing this coming is right here, where it says airbags deployed in 23% of all accidents. Notice there's nothing else. That's it, just airbags deployed. So we might define that to be A. So I might say let A be where the airbag deployed. And then now the morbid B would be, because now they're talking about if a child 32% more likely to be killed in the accident if the airbag had deployed. So the morbid would be child was killed. So now what we can do is start going through and filling in all these different paths. So we already kind of pointed out, 23% of accidents, airbag deployed. So 23% being that, which would mean the rest, the other branch on the diagram, would be the remainder, so that would be 77% did not deploy. So now this is where these problems become interesting, and the goal was on the previous problem for you to realize how this is working out. Now the fun part here is it's saying that they're 32% more likely to be killed if the airbag deployed. So what I'm going to do is define the other option, where if the airbag did not deploy, how likely would they be killed? Well, they don't give us that information. So I'm just going to call it X. So this would be the situation where the airbag, this branch right here would be the airbag did not deploy, but the child was still killed. Now, how likely are they to be killed if the airbag did deploy? Well, we don't know, but we know it's 32% more likely. And this is what the hint they're giving you down here is telling you. It's just whatever this is, how would we add on 32% more? Well, you multiply by 1.32. So the 1 stands for the original 100%. Then the 0.32 would be adding on additional 32%. So when you multiply that by X, whatever X happened to be down here for the likelihood of a child being killed if the airbag did not deploy, this is going to be 32% more. So there's your setup. And we don't need to worry about these situations where the child was not killed because they didn't ask. So now the final part of the question is saying, here, so let me clean this up a little bit in here. So now the question is actually asking, what is the probability that the airbag deployed in an accident in which the child was killed? So they're saying probability. What is the probability? Let me read it one more time. What is the probability that the airbag deployed? What is the probability that the airbag deployed? So that would be a probability of A given B, given that the child died. So we know you're looking after the fact. You say you know the child was killed, so now you're going to go back and look at the car and say, what's the likelihood that this car had an airbag that deployed? And this is where the Bayes theorem becomes so easy if you just do the tree diagram. So you say, okay, which is the desired branch? Now, desired would be a little morbid vocabulary, but desired would mean the path that's going through this A, the path that has the airbag deploying, since that's the way they phrase the question. So this would be the path with my desired outcome. So we're just going to multiply straight down that branch. So it's 0.23 times 1.32x. Then the denominator is just like any other probability. It's desired outcomes divided by total outcomes. Well, so this is one of the outcomes. So it goes in the denominator as well. But then we need to add in the probability of the other outcome, the other branch, which I will highlight actually. The other branch would be following this way, and our first branch was going that way. There we go. So you can see that is 77% times x. Now, we don't need to worry about the other branches, because in both these other branches, we have b prime, or b complement, which means the child was not killed. And that is not what this question is asking. They're saying you know the child was killed, so we can completely ignore those. Those are not legitimate outcomes because we know the child died. So therefore, now we use a little bit of our algebra skills, and this is where the neat part, where the x comes back. A lot of students kind of get nervous when they see that x pop in there, but the neat thing here is it just factors right out of the numerator. That's kind of easy. Then the denominator, notice both terms have an x, so we can factor that out, leaving us with the following work. I need to sneak another set of parentheses in there. There we go. So now, once I divide away my x's, you'll notice we're left with just a set of values that we can compute using the calculator. So I hope that helps. I hope that clears up the big concept for the problem. Best of luck.